Hi everyone, this is the first video for section 9.2 on solving equations using rational numbers. So a lot of this should be familiar for you from college algebra, right? You all had to pass college algebra or test out or what have you. You should all know college algebra. There we go. If you're in this course, so a lot of this is going to be a review from that. So first, a definition. So we have that an equation is an algebraic statement that equates two expressions. So essentially, no matter what's on any side of the equal sign, we have an expression on each side, and then when you have an equal sign, it has an equation. And there's one thing to keep straight, that expressions don't have equalities, and equations do have equalities. And you can see that equal and equation are really similar. They have the same root word. So an equation is a statement that equates two expressions, where an expression is what's on either side. So we have these rules that we can use to simplify equations. So if we add and subtract the same number on each side of the equation, we still have that equality. And if we multiply or divide the same thing on each side of the equation, we still have that equality. So this is how we're used to manipulating equations. We add or subtract or multiply or divide the same thing on both sides of the equation, and that's how we simplify our answer. Everything's still equal. Okay, so we want to solve the equation 13 equals 3x minus 1 using this list of steps that we're given. So we have negative 13 equals 3x minus 1. So the first thing we're told to do is to divide each side by 3. And when we simplify that, we get negative 13 over 3 equals x minus 1/3. Because we have this distributive law of multiplication, we also have a distributive law of division. So you can just do 3x divided by 3 minus 1 divided by 3, where the distributive law extends to division here. Okay, next it tells us to add. Well, here I'm going to put in what I do here between each step in blue. So first we divided by 3, then we simplified. Now I'm going to add 1/3 to each side. And so now 1 plus negative 13 is negative 12 over 3 equals x, because then 1/3 and the negative 1/3 cancel. Then we simplify one last time to get negative 4 equals x. So this is our final answer here. So we solve the equation. And so whenever you're told to solve this equation like this, it may not feel good to you to do it in this way, and that's fine. The order of these steps were chosen to be kind of odd, kind of different than what we would typically do. So typically, we would solve this in a different way, but the order of steps matters, but also doesn't matter. You have a lot of leeway in the order of steps. So as long as the properties of numbers and equations, right? So all the properties of numbers we've talked about thus far, and then these two properties we have of equations that we just talked about. So as long as none of the properties, the properties aren't violated, then the order of steps does not matter. So what a lot of people typically do, so here we divided first and then we added. So we see that we divided, and barring the simplifying steps, we divided and then we added. So we know that what do we know that follows dividing and then adding? Well, we know that the normal order of operations divides and then adds. So this is what this method did. It divided and then it added, and you can really do them in any order you want. However, what most of us would do to solve this problem, if we were solving negative 13 equals 3x minus 1, a lot of us would add 1 to both sides. So then we get 1 plus negative 13 is negative 12 equals 3x. And then we would divide both sides by 3. And we would get negative 4 equals x. And lastly, we would simplify. So a lot of us would do it this way, where you add and then you divide. So when looking at our order of operations, this does addition first and then division second. So we still do addition and division just like before, but we do them in a different order. And this is what a lot of people call reverse order of operations. And that's typically how we think about things. So whenever you're trying to isolate x, which a lot of times is how we think about things, when we isolate the variable, we start by getting rid of the terms that are adding and subtracting to a multiple of that variable. Then we isolate the variable by multiplying or dividing and getting rid of the coefficient. So in simple equations like this, we get rid of the stuff we're adding or subtracting, and then we get rid of the coefficient by multiplying or dividing. And so there's a lot of other strategies to solve equations. We can do factoring, completing the square, but you should have learned those in an algebra class, and they're not that important when doing elementary analysis like we are. So just note that a lot of people tend to use the reverse order of operations. However, the way that I told you to do it up here in the first example, that's still valid. We still got the same answer. We just did it in a different way. So just keep this in mind. Whenever you have students that do things in a little bit different order, because it's still correct. None of it's wrong. It just looks a little bit different than how most of us would think of how to do it. So that's all for this page. So that's all for this video.